Good morning students. Today we are going to discuss an important topic, metallurgy. In every year there is a question for all competitive exams like CET, JEE and Neet. Before going to metallurgy, we have to discuss few basic points about this chapter. Mode of occurrence. Elements occur in two modes, native form and combined form. What is meant by native form? The elements which are low reactive and do not attacked by oxygen, carbon dioxide, non-metals and etc. These are native form. For example, elements like silver, gold, platinum, copper, these all are in native form. Reactivity of these elements is very low and these are not affected by oxygen, carbon dioxide, non-metals and moisture also. Combined form. Elements which are reactive are occurring combined form. These are ready to react with carbon dioxide, oxygen, non-metals and even with moisture also. So these are reactive. So they occur in combined state. And we have few non-metals such as carbon, sulfur can exist in both native form as well as combined form. This you have to remember. Carbon and sulfur are occur in native form and combined form. So how to remember this native form and combined form is, we have a small trick, that is metal reactivity series. In metal reactivity series, potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead. We have above the hydrogen. The metals which are present in metal reactive series above the hydrogen are more reactive. More reactive means they are in existing combined state. Metals like copper, silver, gold and platinum, these are present below the hydrogen in metal reactivity series. These are least reactive, which are least reactive are not affected by oxygen, carbon dioxide, non-metals. So these are in native form. So like this elements exist in two forms. So this you have to remember metal reactivity series. Then you can easily remember which are native and which are combined form. Next, abundance of elements. So abundance of elements not in same ratio. Different elements abundant in earth crust in different percentage. For example, you go for oxygen. It is in 49.5%. And you go for next silicon. Silicon is nearly 25.7%. Next you go for aluminium. This is nearly 8.31%. And next you go for iron, nearly 4.7%. and you go for next calcium nearly 3.4%. Means in earth crust different elements exist in different ratios. Most abundant element is oxygen, second most abundant element is silicon, third most abundant element is aluminum. First three you have to remember. Next, among the metals, most abundant metal is aluminum. Among the elements oxygen, among the metals aluminum. Second most abundant metal is iron. Second most abundant element is iron, and this is the percentage of existence or abundance. Generally, elements abound in earth crust in the form of minerals and ores. Minerals and ores. In the form of minerals and ores. What is meant by mineral and ore? Let me go for what is meant by mineral. A mineral is a naturally occurring chemical substance in which metal occur in earth crust. Mineral is a naturally occurring chemical substance in which metal occur in earth crust. And ore, the form of mineral. Ore also the form of mineral, from which metal can be economically and conveniently extracted. It is naturally occurring chemical substance which metal occur in earth crust, and it is the mineral form from which metal can be economically and conveniently extracted. Conveniently extracted is called ore. Here we have to discuss one main important thing. All ores are minerals. All ores are minerals. But all minerals are not. All minerals are not ores. Are not ores. Let me discuss the difference. Generally, elements occur in different forms. For example, you go for aluminum. Aluminum exists in the form of bauxite as well as clay. Bauxite and clay. Formula for bauxite is An2O3 2H2O, and formula for clay is An2O3 2SiO2 2H2O. Both are forms of aluminum only. One is bauxite and one is clay. You go for both bauxite having water and oxygen, and clay having silicon dioxide, hydrogen and oxygen. Means in clay we have the impurities more. Impurities more. Impurities nothing but which are unwanted substances. You go for bauxite. In bauxite only water molecules and oxygen is there. So it is very easy and economically profitable and convenient to extract aluminum from bauxite than clay. That's why bauxite is ore, whereas clay is only mineral. So here we discussed already the definition for mineral and ore. Ore nothing but the mineral form. So bauxite is the mineral form only, which the metal can be economically and conveniently extracted. So it is easy to extract from bauxite. That's why we are selecting only ores. Now, here we discussed that an element can exist in different forms. Already we discussed about aluminum. You go for like that iron. in different forms. The main forms I am writing here, that is hematite, magnetite and siderite. So iron exists in three forms. One is hematite, the next one is magnetite, the next one is siderite. What the formula for this hematite, magnetite, siderite means? Hematite is Fe2O3 and magnetite is Fe3O4 and siderite is FeCO3. Hematite, magnetite and siderite. This Fe3O4 we are calling as magnetic oxide, also important for competitors. Which iron oxide or iron mineral is called as magnetic oxide? That is Fe3O4, that is magnetite. Why it is called as magnetic oxide means it is ferrimagnetic substance. That's why we are calling as magnetic oxide. Or another name we have, that is lodestone. Remember this. Magnetite is well known as magnetic oxide or lodestone. And next, another we have metal, that is copper. Copper also exists in different forms. That is in copper sulfide form, Cu2O form, CuCO3, CuOH twice form, means sulfide form, oxide form, carbonate and hydroxide form. And you go for sulfide, oxide and carbonate forms and their names. First we will go for the carbonate form. This is we are calling malachite. CuCO3, CuOH twice, malachite. And Cu2O we have. This is we are calling cuprite. And now we have copper sulfide. This copper sulfide we are calling copper glans. What we are calling? Copper glans. So like this, copper exists in three forms: copper glans, cuprite and malachite. This you remember that one important thing we have here, Cu2S, that is copper glans, is known as ruby copper also. What we are calling? Ruby copper. Which copper mineral is well known as ruby copper means copper sulfide. This you have to remember for competitive concept. And we have another metal, that is zinc. Zinc also exists in different form, that is in zinc sulfide and zinc oxide, that is sulfide form, oxide form and in carbonate form also. Zinc sulfide, zinc oxide and zinc carbonate. And here very important mineral we have, that is zinc carbonate, we are calling as calamine. Which is we are calling as calamine? Zinc. Which zinc ore we are calling as the calamine or mineral calamine? Zinc carbonate. Zinc carbonate calling as calamine. And this is we are calling zinc glans. And this is we are calling zincite. What we are calling? Zincite. Zinc sulfide, zinc glass. ZnO is called as zincite. ZnCO2 is called calamine. So this is important for competitive concern. Like this, different elements exist in different forms. Then we will go for another important point for competitive concern, that is Cl. Some elements in oxide form, sulfide form, carbonate form and hydroxide form, like that. Now, elements which are in sulfide form, Cl, copper glands, zinc glands, these are in sulfide form. Generally, the sulfide form occur in rocks. Remember this. Minerals which are in sulfide form occur in rocks. Why these are occurring in rocks only means metal sulfides are insoluble in water. Remember, metal sulfides are insoluble in water. That's why they are in rocks. And some we have in the form of halides. That is metal halides. These are occur in the form of occur in lakes and in sea. Why these are present in lakes and sea means metal halides highly soluble in water. That's why these are present in lakes and sea. This is the point you have to remember. Why sulfides are present in the form of rocks? Why halides are present in the form of in sea and lakes means that you have those are soluble in water and these are insoluble in sulfides are soluble in water, halides are highly soluble in water. That is the basic points which are present in metallurgy. Now let me go further. What is meant by metallurgy? Metallurgy nothing but the process of extraction of metals. It is the process of extraction of metals from their ores. Metallurgy nothing but the process of extraction of metals from their ores. But it is a big process, extraction of metals. Why means in any ore along with metal some impurities are present. These impurities we are calling as gangue or we are calling matrix. First we have to remove this. That's why first we have to identify the impurity, what type of impurities are present. So here we are going to discuss about extraction of elements. So extraction of elements. Elements may be metals or non-metals. First, extraction of non-metals. So this is a simple process. Non-metals can be extracted by electrolysis process. Electrolysis process. Non-metals can be extracted by electrolysis process. For example, chlorine electrolysis. Chlorine electrolysis. When chloride ions subjected to electrolysis. What I am doing? I am preparing chlorine by electrolysis method. I took here chloride ion. Chloride ions are treated with water, that is electrolysis. Then I am getting chlorine gas. Chlorine gas. So OH minus ions, water plus chlorine gas. When chloride ions are subjected to electrolysis, and I am getting OH minus ions, chlorine gas and hydrogen gas. And this is in aqueous position, and this is aqueous position, and this is in liquid. Non-metals extraction by electrolysis method. Here I am preparing chlorine gas. When chloride ions subjected to electrolysis, I am getting chlorine gas. By this method we can we can prepare remaining non-metals also. Now, extraction of metals. Extraction of metals from their ores is a big process. Here, different steps are involved. The process of metallurgy, depending on nature of ore and impurities. So metal extraction. In metal extraction, the process of extraction is depending on type of ore or type of impurities. This you have to remember. The process of metallurgy depending on the nature of ore and impurities. This is the point you have to remember. Nature of ore and impurities. So extraction of metals involves in three steps. That is, first step we have concentration. This is we are calling grinding also. After concentration of ore, we have to extract. That is extraction. Here we are getting crude metal. And the third step, very important step, that is we are getting purification. This is we are calling as refining also. So extraction of metals, that is the process of metallurgy, depending on nature of ore and impurities. Here three steps are involved: concentration and the extraction. Concentration we are calling as grinding also. Extraction, what we are extracting means crude metal. After getting crude metal, that will be purified or refined. So purification or refining. And before going to next, we have to discuss few important questions for competitors. What type of questions they are asking from basics? For example, the question is given previously: formula for calamine. Option A, ZnS. Option B, FeCO3, FeCO3. Option C, ZnCO3. Option D, Cu2s. Cu2s. Calamine formula they asked. First we have to remember that calamine mineral is belongs to which metal? So as I given here, calamine is as zinc mineral. Here we have zinc mineral. Zinc mineral. So our answer is zinc carbonate. Zinc carbonate. Next, another question given like this. The magnetic oxide of iron. The magnetic oxide of iron is option A, Fe2O3. Option B, FeO. Option C, FeS. Option D, Fe3O4. Fe3O4. So here we have hematite, ferrous oxide, ferrous sulfide, magnetite. So as I given previously, magnetite is a magnetic oxide. Magnetic oxide. So as we learned before, Fe3O4 is called as magnetic oxide. And few more questions I am giving to you. How they are asking in basics. That is, bauxite is ore of dash. That is first one barium, next one beryllium, next one bismuth, next one aluminum. Bauxite is ore of, previously we learned that bauxite is ore of, go for here, bauxite is ore of aluminum. So our answer is aluminum. And you go for it. Formula for ruby copper is, question is, formula for ruby copper is, ruby copper, ruby copper, ruby copper formula, ruby copper formula. Which one we are calling as ruby copper? Ruby copper is, previously we discussed already, ruby copper that is belongs to copper mineral. Ruby copper is copper mineral. So the options we have to select any one that is ruby copper formula. Ruby copper formula. That is whether copper oxide or copper sulfide or copper carbonate or some other formula. Option A. Cu2O. Option B, Cu2s. Option C, CuO. Option D, CuFeO3. So here, sorry, it is Cu2O, ruby copper, and ruby copper formula is Cu2. That is Cuprite is called as ruby copper. Cuprite is called as ruby copper. Cuprite is called as ruby copper. Like this question they will ask for your competitive in basics. In next class we will discuss about extraction of metals. Thank you. Good morning students. Today we are going to discuss an important concept from metallurgy, that is concentration of the ore. What is meant by concentration? Removal of impurities like sand, clay from metal ore is called concentration. Removal of impurities from metal ore is called concentration. What are the impurities means? Sand and clay. Concentration involves several steps, and selection of these steps depending on difference in physical properties of metal and gangue. So different steps we have. Selection of step depending on difference in the physical properties of metal ore and gangue. We have different concentration methods like gravity separation, This gravity separation, well known as hydraulic washing. Hydraulic washing or levitation And another method we have, that is froth flotation and magnetic separation. The fourth one we have leaching process. So concentration of the ore can be done by gravity separation or hydraulic washing or levitation, froth flotation, magnetic separation and leaching. Let me discuss in detail about these methods. First one, gravity separation, or we are calling hydraulic washing or levitation. In gravity separation, what is the principle we are using means based on difference in gravities of metal ore and gangue. Gangue nothing but impurities. If gravity difference is there, then we are doing gravity separation. And this method we are using generally for oxide ores. Oxides ores can be separated, that is concentrated by this method. To concentrate by this method, we have hydraulic classifier, And the next one we have Winfrey washing table. Winfrey washing table. By using hydraulic classifier and a Winfrey washing table, we can concentrate the work by gravity separation. Now let me discuss about hydraulic classifier. Hydraulic classifier. Hydraulic classifier is a large conical reservoir. Large conical reservoir. Here I am drawing large conical reservoir. It contains large conical reservoir. And this is hydraulic classifier. It contains a large conical reservoir and this is and with two inlets. This is top of the reservoir. We have one inlet, that is we are introducing the ore from it, and this another inlet we have here, bottom of the reservoir. We are introducing water from it, and two outlets, one gang outlet and the another one we have concentrated ore outlet. This is the structure of hydraulic classifier. And there is a provision in this to remove lighter gang particles from the top and to collect concentrated ore from the bottom. Then a powerful stream of water is introduced into the reservoir, and same time powder form ore is introduced from the hopper. Then we are getting suspension of ore. Suspension of ore. We are getting suspension of ore. And heavier particles of metal ore collected from the bottom and lighter particles, gang particles collected from the top of the reservoir. And this is the method we have in gravity separation. And what type of metals can be separated by this method means like iron, gold, chromium. And here we have to remember that ore particles should be more denser than gang particles. Ore particles should be more denser than gang particles. Then this method can be applicable. This is hydraulic classifier. And Winfrey washing table, all of you know in your class 10 you already completed. And next method we have that is froth flotation. Froth flotation. So let me discuss about froth flotation. Froth flotation. In froth flotation, what the principle included means, the principle is difference wetting property. Difference in the wetting property of metal ore and gangue particles. Difference in the wetting property of the metal ore and gangue particles. And here we have to remember that ores like sulfides, means sulfide ores, can be concentrated by this method, like lead sulfide, mercury sulfide, zinc sulfide. Means only sulfide ores are concentrated by froth flotation method. This is lead sulfide we are calling as galena, and this is mercury sulfide as cinnabar, and this is zinc glands. Zinc glands. These are concentrated by this method. And here one more thing we have to remember, that ore particles should be low density. So this is a reverse to gravity separation. In gravity separation, ore particles are more denser than gangue particles. Here, ore particles should be in low density than gangue particles. And here the method we have how to extract by this method. And here we are taking along with ore plus oil plus water and a rotating pedal like this, use it to rotate. This is the arrangement. Here the powdery form of ore is mixed with water and then a suspension will be formed. A suspension of ore and water is taken in a vessel. To this, two types of chemicals are added. One is collectors. The next one is froth stabilizers. So suspension of ore and water is added by collectors and froth stabilizers. What are the collectors we are using here means collectors like pine oil, or you can use olive oil, camphor oil, whatever it is. pine oil, fatty acids and xanthates. What are the characters used in this method? Pine oil or olive oil or camphor oil, fatty acids, xanthates. And froth stabilizers we are using. Froth stabilizers we are using as aniline and cresols. Aniline nothing but amines, cresols. So this can make the method perfect. Now what are the activities of these collectors and froth stabilizers? So here we are going to discuss in detail about this. So collectors we are using and froth stabilizers we are using for stabilizers. How this will work? Here pine oil, what it will do means it will generate froth. So pine oil or any olive oil or camphor oil, it generates the froth. And froth stabilizer we are using as aniline or cresols. This froth will be stabilized. So pine oil generate froth, aniline or cresols are stabilize the froth. And here we have, that is xanthates, that is fatty acids. These are fatty acids and xanthates. Enhance the non-wettability. Enhance the non-wettability of ore particles. See, pine oil or any other oil will make the froth. Froth stabilizers like aniline, cresols stabilize the froth. Then fatty acids or xanthates as collectors we are using can enhance the non-wettability of the ore particles. Then top of the vessel, froth is generated. When we rotate this pedal, this froth moving to the top along with ore particles. Because I told already, ore particles are having the low density. This froth is collected. Into another, and then that will be dried out and recovering of concentrated ore is done. This is the method we have here in froth flotation. But when ore consists two types of sulfides. For example, zinc sulfide and lead sulfide ore we have. When two sulfide ores are mixed in a particular ore, then this separation will be done by adding some chemical substances, that is we are calling depressants. When the ore is mixed with two different sulfide ores like zinc sulfide and lead sulfide, one is considered as the impurity, one is as the ore. Then we are adding depressants. What type of depressants we are using means like sodium cyanide. Sodium cyanide is going to be used, and activators also we are using. Activators. What are the activators we are using means copper sulfate or sodium sulfide. Sodium sulfide. If the ore having two types of particles, that is zinc sulfide and lead sulfide, we are using depressants like sodium cyanide, and an activator also added, that is maybe copper sulfate or sodium sulfide. What this represent will do means it stop the impurities. For example, zinc sulfide is impurity. How can we know means which is less in amount, that is impurity, which is more in amount, that is ore. So this depressant will stop moving along with the froth. These activators will help moving along with froth. So like this, depressants and activators we are using. When a depressant is added, how it prevent movement of ZNS along with froth means when ZNS treated with or ore is treated with sodium cyanide means this depressant react with ZNS and making a complex, that is sodium tetracyanozincate. So when zinc sulfide converted into insoluble complex like sodium tetracyanozincate, then it will not move along with the froth, but lead sulfide is moving along with the froth with the help of activators like copper sulfate and sodium sulfide. This is the froth flotation method we have. Next, magnetic separation. How magnetic separation is going to be carried out? Let me discuss. Magnetic separation method is very easy method. Magnetic separation. What is the basic property here we are using means it is based on differences in magnetic properties. Differences in magnetic properties of metal ore and gang particles. So gravity separation is a difference in gravities. Froth flotation is difference in wetting property, And magnetic separation is difference in magnetic properties of metal ore and gangue particles. This is the main. Here we have an arrangement like these two magnetic rollers. Magnetic rollers. These magnetic rollers are connected with a conveyor belt. Conveyor belt. These two are magnetic rollers connected with conveyor belt, and it is attached with a hopper. With a hopper. Hopper is the arrangement where powdery form ore is going to be introduced. So this is ore particles we are introducing here. Powdery form ore particles. So this is magnetic roller. Magnetic roller. And this is conveyor belt. Conveyor belt. And here we have collectors of ore particles and gangue particles. When powdery form ore particles introduced onto the conveyor belt, these are magnetic rollers we have along with a conveyor belt. It is moving on like this. Then the ore particles are moving along with conveyor belt, and this is a magnetic roller. If this ore having magnetic particles, those will be attracted and getting here near to the roller. If the ore having magnetic particles, that will be attracted by the magnetic roller and will collect here. Non-magnetic substances or particles are present. These we are collecting here. So this is magnetic particles and this is non-magnetic particles. Like this, we can collect magnetic particles and non-particles. And these are, we are calling gangue particles, and this is concentrated ore particles. Concentrated ore particles. This is magnetic separation. Magnetic separation. See, gravity separation, froth flotation, and magnetic separation. These all are physical methods. These all are physical methods. And another physical method we have, that is hand picking method. This is in our schooling. Sand, stones are picked out by hand. Hand picking method also physical method. By this method, what type of ores are concentrated means generally hematite. Remember, hematite is concentrated by hand picking method. Next, another method we have, that is leaching method. Leaching is a chemical process. That is chemical method. What is the main process here means, when ore is soluble in a particular solvent, if the ore is soluble in a particular or suitable solvent, then this method we are applying. What type of metals or ores are concentrated means like aluminum ore can be concentrated by this method, silver, gold. Aluminum, silver, gold are concentrated by a chemical method called as leaching. Let me discuss what is included in this. Leaching of aluminum from bauxite. So leaching of alumina from bauxite. You know very well, bauxite is aluminum ore. You know formula for bauxite, Al2O3 2H2O. From bauxite we are extracting aluminum, means concentration of bauxite to get aluminum. What we have to do here is, ore is treated with concentrated NaOH solution, concentrated NaOH solution at 473 to 523 Kelvin temperature and 35 to 36 bar pressure. This is the condition. 473 to 523 temperature, 35 to 36 bar pressure. Then it will be getting into a chemical reaction. We are getting sodium aluminates. Sodium aluminates. Let me show it. Al2O3 2H2O. This is in aqueous position, and we have to add sodium hydroxide. Sodium hydroxide. This is also in aqueous position along with water, and this is in liquid. Condition is 473 to 523 Kelvin temperature, 35 to 36 bar pressure. At this position, we are getting a complex sodium aluminate. Sodium aluminate. So here we are getting sodium aluminate. Sodium aluminate. This is sodium aluminate. So a complex sodium aluminate is going to be formed. A complex sodium aluminate is going to be formed. And impurities such as silicon dioxide, tin oxide, iron oxides are present in this ore. If silicon dioxide is present, this silicon dioxide react with concentrated sodium hydroxide and removed as sodium silicate. Removed as sodium silicate. Removed as sodium silicate. Then this sodium aluminate is neutralized by carbon dioxide. Neutralized by carbon dioxide. Sodium aluminate is neutralized by carbon dioxide. This is aqueous position, and carbon dioxide is a gas. It is neutralized by carbon dioxide. When sodium aluminate neutralized by carbon dioxide, we are getting hydrated aluminum oxide precipitate. Hydrated aluminum oxide precipitate. So, hydrated aluminum oxide precipitate is going to be formed. This is hydrated aluminum oxide precipitate that is going to be formed here. Then, from this, how can we get concentrated alumina? Means this hydrated aluminum oxide is going to be heated at high temperature. Look here. Al2O3 XH2O is treated with at 1470 Kelvin temperature. Then this is aqueous. This is solid in form, and you are getting Al2O3 solid and water is going to be in it. This is the solid form. Concentrated Al2O3 is going to be collected. This is we have leaching process, especially leaching of bauxite to get alumina. Similar manner, we can leach silver and gold also. Silver and gold. Leaching of silver and gold. Leaching of silver and gold. Here ore is treated with silver ore or gold ore. For example, if you need silver ore, Ag2S, here we have silver ore, like that. Argentite, silver ore we have argentite. This is treated with a sodium cyanide or potassium cyanide in the presence of air. Treated with diluted sodium cyanide or potassium cyanide in the presence of air. Then we are getting respective concentrated ore. And this here we are cyanides we are using, that's why we are calling cyanide method. Cyanide process. And you go for it. Now, 4 moles of metal which is in solid position, 8 moles of cyanide which is in aqueous position, treated with air, nothing but oxygen. This is the reaction. Metal, ore, cyanide, aqueous solution, and this is oxygen. Gas. This is the reaction method. Then we are getting a metal complex. That is metal cyanide complex. Metal cyanide complex. I am getting. This metal cyanide complex which is in aqueous state. This metal cyanide complex further treated with zinc metal. And this is in aqueous and this is in solid position. When zinc is treated with this metal cyanide complex, you are getting zinc cyanide complex. zinc cyanide complex. Zinc cyanide complex, which is in aqueous position, and concentrated metal going to be connected here. This is leaching of silver and gold. Good morning, students. Today we are going to introduce an important concept from metallurgy, that is extraction of crude metal from concentrated ore. Extraction of crude metal depends on nature of ore and impurities. So, extraction of crude metal depend on nature of ore and type of impurities. In this process, two steps are involved. That is conversion of concentrated ore to its oxide form. This is the first step. Step 2. Conversion of oxide ore or oxide form to crude metal. These are the steps involved. Now first one, let me discuss conversion of concentrated ore to oxide form. So we have to convert concentrated ore to oxide form. That is, in this method, oxidation takes place. What is the method we have here? Oxidation. Conversion of concentrated ore to its oxide form can be done by oxidation. Here, two methods are involved. One is calcination and the next one is roasting. Calcination and roasting. What is meant by calcination? Look here, calcination. Calcination nothing but heating the ore in absence of air. Heating the ore in the absence of air. This is we are calling calcination. So here what we are doing means concentrated ore going to be heated in the absence of air. For example, zinc carbonate is subjected to heat in the absence of air. We are getting zinc oxide and carbon dioxide. This is zinc oxide. Similarly, Fe2O3 X water molecule are subjected to heat. hydrated ferric oxide. Then it will give ferric oxide and water, X moles of water. This is ferric oxide. And you take dolomite, CaCO3, MgCO3. This is we are calling dolomite. It is subjected to heat. It is subjected to heat. Then we are getting calcium oxide, magnesium oxide and carbon dioxide. Like this, in the absence of air, we are heating the concentrated ore. Then you are getting respective oxides. So this is the steps here we have. Conversion of concentrated ore to its oxide form. So zinc carbonate converted to zinc oxide, hydrated ferric oxide converted to ferric oxide, and dolomite carbonate form converted into oxide form. So we got oxide form. During this method, what the changes will take place means changes are takes place, that is volatile impurities are escaped. Volatile impurities are escaped. Then water is removed. Water is removed from hydrated salts. Hydrated salts. That is hydrated ores. Carbonates converted to oxides. If any moisture is there, that moisture also removed. These are the changes takes place during calcination. Volatile impurities are escaped, water removed from hydrated ores, carbonates converted to oxides, and if any moisture is there in the ore, that also will be removed. These are the changes. The next one we have roasting. Let me go for about roasting. What is meant by roasting? What is meant by roasting? Look here, we completed calcination. Calcination nothing but heating the ore in the absence of air and removal of impurities, and concentrated ore is converted into oxide form. Next, roasting. What is meant by roasting? Roasting also is a heating process like calcination, but small difference is there. Heating the ore strongly. Heating the ore strongly. Heating the ore strongly in the presence of air. In the presence of air. Calcination in the absence of air. Roasting in the presence of air. That is, air should be excess. At high temperature. At high temperature. Below the melting point of metal. So we have to heat strongly and at high temperature, but it should be below the melting point of metal. If we heat more and more above its melting point, metal will be melted. That's the problem. Then in this process, what the changes takes place? Generally this process for sulfide ore converting into oxides. Remember, this is very important point. This roasting process is only for to convert sulfide ore to oxide ore, not for all. And the impurities are removed. Impurities are removed, such as sulfur, arsenic, phosphorus, in the form of their oxides. Sulfur in the form of sulfur dioxide, arsenic in the form of arsenic trioxide, phosphorus in the form of phosphorus pentoxide. Like this, these are removed. If moisture is there, that moisture also removed. Moisture also removed. Let me go for what the changes. For example, where I told already sulfide ores are subjected to convert into oxide. I am taking zinc sulfide. Zinc sulfide. It is strongly heated. Heating means in the presence of air, I told, that's why oxygen is added. Then zinc sulfide converted to zinc oxide plus sulfur dioxide is evolved. Sulfur dioxide is evolved. Sulfur dioxide is evolved. And similarly, lead sulfide. I am taking lead sulfide also. PBS. This is we are calling galena. In the presence of oxygen gives lead oxide and sulfur dioxide. Lead sulfide galena, zinc sulfide, zinc glands also we are calling zinc glands. Like this, they form oxides. Similarly, I am taking one more oxide, that is copper oxide, copper sulfide. This copper sulfide subjected to heat in the presence of oxygen gives copper oxide plus sulfur dioxide. Copper oxide plus sulfur dioxide. You know very well, this is we have called as ruby copper. Ruby copper. Remember this. Which copper ore is known as ruby copper means Cu2. Like this, in roasting, sulfide ores are converting into oxide ores. Sulfide ores are converting into oxide ores. Now, during conversion of these sulfide ores to oxide ores, this total process takes place in reverberatory furnace. Total roasting process taking place in reverberatory furnace, where roasting takes place in reverberatory furnace of copper sulfide. If this copper sulfide contains contains impurities such as iron. If copper sulfide consists impurities such as iron, immediately silicon dioxide is added before heating. So where you are doing roasting process of copper sulfide, if it is contains iron impurities, before heating only silica is going to be added. What happened means this iron silica react with this copper sulfide, form iron silicates. So iron form iron oxide and it react with silicon dioxide and form iron silicates. And this iron silicate in the form of slag. Slag nothing but easily fusible substance. But this iron silicate is formed in the form of copper sulfide plus a little bit iron sulfide. So slag is formed in the form of the mixture of copper sulfide and iron sulfide. The mixture of copper sulfide and iron sulfide, well known as copper matte. Very important for exams. What is the composition of copper matte? Cu2s plus Fe(S), copper sulfide and iron sulfide. It is more in percentage, it is less in percentage. The mixture of the composition of copper sulfide and iron sulfide is known as copper matte. Like this, calcination and roasting will be takes place. Next, the second process, second step, we have conversion of oxide to crude metal. Conversion of oxide to crude metal. Conversion of oxide from crude metal. In this process, carried out in the presence of reducing agents means it is a reduction process. It is, I told already, oxidation process. Conversion of concentrated ore to oxide form is oxidation. Conversion of oxide form to crude metal is a reduction. That's why here we are using reducing agents. What reducing agents we are using here means coke, carbon monoxide or any other metal. Any other metals we are using. So here, where we are using reducing agents, pyrometallurgy will takes place. Means the process of extraction of metal